Okay, so for this question, this question is a very common kind of problem. Okay, so this question is continuous median. Okay, and the idea is also very similar, very simple. Okay, such that so this question is actually you are given an array and you need to find the median of the array. Okay, that's all. But the catch is right. Okay, the catch is you need to calculate the sum of all the medians as the element is added into the array. So that means you start off with an array of size 1. Then you add in one element, then you ask yourself, what is the median of this new array? Then you add in one more element, then you ask yourself, what is the median of this new array? So given from this test case, right, notice the array is, at first is one element containing 1, so the median is 1. Then if you add in one element, it becomes 1 to 1, 3, then the median is basically the average of the middle two elements, which is 1 plus 3 divided by 2, which is gives you 2. Then you add in one more element, 6. So if the size is an odd number, the answer is just the middle element, 3. Okay, etc. So you notice, right? As I add one element in, then what happens is I need to sort the array, then you find the middle value. Then you need to add up all these medians, and then you output the final answer. Okay, so hopefully when you see this, right, your idea will be, oh, what if you just implement it naively? That means you have an array, okay, you start with an array, and then you find the median by sorting it and then selecting the middle element. Then after that, the next query, you add in one more element, so it becomes A, B, right? Then you sort it, find the middle element, then you add in one more element, A, B, C, you sort it, find the middle element, etc. So you notice if you have to keep sorting at every step, each sorting step is O n log n, right? O n log n. Okay, O n log n. But then, right, you have a total of n items in this array, which means you're going to do this n times. So your complexity in total will be O n squared log n, okay, which is far too slow. So therefore, right, you need to think of a faster method to do it. Okay, you might notice that this is definitely the step that is taking too long. O n log n at each step is really too slow. Okay, given the value of n, so what is the value of n? The value of n in the worst case is actually 10 to the power of 5. Okay, so therefore this is too slow. Okay, this will definitely fail. Okay, you need to find a way, right, in order to find the median in the shortest time complexity possible. Okay, so what's the technique? Okay, so notice, right, this question is actually very similar to your lab assignment, your weekly assignment 2B, which is this word, right? Okay, where you need to implement a gets middle. Okay, so remember how you actually solve. Okay, actually you have, okay, some of you may not have solved it, so maybe I will not explain how to do it. Okay, so yeah, okay, so I realize some of you may not have already done it, so maybe I'll give you a variant. Okay, so this is the question that is very similar to your assignment. Okay, in a sense, right, that you need to create your own data structure. Okay, you need to create your own data structure, and you also need to have something that tells you what is the middle element at each time. Okay, so how do I solve this question, right? Continuous median is that you understand that a median, right, is the middle element of a sorted array. Okay, and to the left of the median, okay, these elements are all smaller than the median, and to the right of the median, these elements are all larger than the median. Okay, and you notice, right, that this, if in a sorted array, for example, the median is 6, right? 7, 9, 13. For example, in a sorted array, these elements here, okay, will be in ascending order, right? And these elements here will also be in ascending order. Okay, but you're not really interested in this because you're only interested in the middle element. But you notice, right, that if the size of the array is an even number, then you have two middle elements, which you need to find the average of. So in other words, you need to be able to access this element 5 and this element 7 as well. So you notice, right, what is this? What property does this hold? So this is 1, 4, 5, right? Okay, but you want to access the top element 5, which means you need this to be in sorted order, so you use a max heap. Okay, use a max heap for this. Okay, then for this, you need to access the top element, which is 7, which is the smallest number in this sorted array. So here you have a min heap. Okay, so I hope you understand what a heap is. A heap is basically a dynamic data structure where you can add an element in and it will help you sort it. Okay, it doesn't really sort it, okay, but it helps you position it properly so that when you want to find the top element, it's able to do the bubble up operation in log n time, so that you can obtain the element that has the highest priority. In the max heap, the element with the highest priority is the largest element. In the min heap, the element with the largest priority is the smallest element. Okay, so this is an log n approach. Okay, so what you do, right, is that you don't need to care about the median. You actually just need to have two heaps. One max heap that's storing elements on the left of this array, and one min heap that's storing elements on the right of this array. Then how does this implementation work? Okay, this is more implementation heavy. Yeah? So you just imagine, right, you have a max heap here, okay, and you have a min heap. So at the start, both are empty, right? Okay, so for example, now you have one element, 5, okay? If I have 5, both are empty, doesn't really matter. I just put 5 inside this max heap. 5 will obviously be at the top of the heap, right? Okay. Now, what is the median? The median will be the top element in the max heap, correct? Okay, so now let's say, right, I add in a new element 3, okay? 3. So what is my algorithm going to be like? Okay, my algorithm, right, is going to decide, should I place 3 in the min heap or in the max heap? Okay, so what I do is I just need to check the top element in the max heap. If this element is smaller than the top element in the max heap, I will transfer the top element in the max heap to the min heap. So 5 will be placed here, and then 3, I will place it in here, in the max heap. So you notice my array will still be sorted 3, 5, right? And then the median, because the size of the array is now an even number, so the median will just be the top element in the max heap plus the top element in the min heap divided by 2. So the answer will be 4. Okay? Then we do the same thing. Now, right, I have, for example, right, okay, for instance, I have the element 8. Okay, so what I do is that 8 is larger than 3. Okay, so perfect. But 8 is also larger than 5, which means I need to do another swap operation. 5, remove it, place it in the max heap. So 3, 5 will be like that. Remember the heap, just assume that it helps you sort it first, okay? Then 3, 5 is in the max heap. 8, I place it into the min heap. So the answer will be 3, 5, and 8. Notice if the size of the array is an odd number, the median will just be the top element in the max heap only, which is 5, right? So this is the algorithm. This is all. Okay, this is the algorithm. Okay, let's imagine I have another element 1. Okay, I have an element 1. So 1, you notice, is smaller than 5, right? So I need to place it in the max heap. But notice the max heap will be over-numbered. We'll have 3 elements, and the min heap will only have 1 element. So I still need to do some shifting. The top element, remove, place it back in the min heap. So 5 will be placed here. 1, I'll place it into the max heap. So 1 will be placed here. So here the max heap will be consist of 1 and 3. The min heap will consist of 5 and 8. And remember the size of the array, size of the array is now an even number. The median is the top element in the max heap, which is 3, and the top element in the min heap, which is 5. Add them together and divide by 2. Median is 4. Okay, that makes sense, right? The array is 1, 3, 5, 8. So this is how you sort an array. Basically, you don't actually sort it using the sort method in Java. Instead, you use 2 heaps to ensure that you can sort in log n time. Because every time you insert, the heap will help you bubble down in log n time. Then if you want to find the topmost element, it will bubble up in log n time as well. So all operations are log n, and you have total of n items. So the complexity, right, is actually n log n for this solution. Okay, so the idea is very similar to your graded assignment, where you create, okay, one on the left, one on the right, and then you decide how you obtain the element in the middle, how you obtain the elements on the left and right, and whether there's any shifting that needs to be done. Okay, so this is how you solve this problem. Okay, the complexity is also on n log n. Okay, so I am